All right, in this lesson video, we're going to be reviewing Chapter 10, all about circles. So this is a 20-question review. There's one bonus at the end. I'm going to try and break it up into small videos because it takes forever to upload if it's 45 minutes. So for questions 1 through 3, use circle D. Name a radius. So here's our circle. We have a diameter, which goes all the way across. And of course, a diameter is made up of 2 radii, right? So we've got AD or DB. So are any of those choices? AD, is that a choice? Nope. DB is, I'll highlight it right here, B. Excuse me. These allergies are horrible. Number 2, name a chord that is not a diameter. Remember, a chord is a line that goes across a circle. Both endpoints of the line lie on the circle, but it doesn't go through the circle. So chords would be AB and CB. Right here. Now, line CB is a secant, but segment CB, we could call that a chord, right? There's not really any other options. AB is a diameter, and it says what's not a diameter. So, line segment CB, this guy right here. Number 3, name a secant. A secant is similar to a chord, except instead of stopping at the circle, instead of being a line segment, it's an infinite line. So, it actually goes through the circle and keeps going, right? AB doesn't go through the circle. This line right here, CE, doesn't go through the circle. It's tangent to the circle. It touches the circle in one spot. This line CB, not segment CB, but the entire line CB goes through our circle. So line CB, see how it has the arrows on the top when we name the line? Up here, it's segment CB, so there's no arrows. This is going back to like Geometry 101, how to name a line or a line segment. Okay, number 4. The circumference of a steering wheel of a car is 20 pi inches. What is the radius of the steering wheel? Remember circumference equals 2 times pi times r, or diameter times pi. Because 2 radii is the same thing as the diameter, right? So if our answer is 20 pi, we have 20 pi equals the circumference, which is 2 pi r. How can I solve for radius? Well, I can divide both sides of my equation here by 2 and by pi, right? So that's what I'm going to do. I'm going to divide this side by 2 pi, and I'm going to divide this side by 2 pi. So over here, those cancel, and I'm just left with r, which is what I want. I want to solve for the radius. Here, the pi's cancel. Pi divided by pi is just 1. And 20 divided by 2 is 10. So my radius is going to be 10f. This guy here. Number 5. Find the measure of arc GH. Let me move this around so I'm not looking at that work. Find the measure of arc GH in this circle that it shows us right here. I'm going to zoom in on this a little bit. Oops. This guy. All right, so for circle F here, it's named F, we're looking for this portion, right here. Find the measure of this arc, right? So I need to figure out, the measure of the arc is the same as the central angle, so I need to figure out what this central angle is right here, okay? Well, this is a straight line right here, so I know these 3 angles together add up to 180 degrees. This one's 90. It's marked 90 in the corner. This little sliver, it says right here, it's hard to see, but it says it's 20 degrees. And then 20 plus 90 plus what adds up to 180. 20 and 90 is 110. So this guy has to be 70. And the measure of an arc, not the length of the arc, the measure of the arc is the same as the measure of its central angle. So this is a 70 degree arc. So our answer here is C. Okay, backing up a little bit. Number 6. Up to the top. There we go. Okay, number 6 here. Points G and H lie on circle T, so that TH is 8 meters and the measure of angle GTH is 45 degrees. Find the length of the arc to the nearest hundredth. So we're looking for arc length now. So let's go ahead and make a picture. Here's my circle. It's circle T, so I know point T is the center. And it says TH is 8 meters if G and H lie on the circle. So I'm going to put point H right here. And the distance from here to here is 8 meters. I'm going to do it in black. Here to here is 8 meters. And what do I also know about this? If T is the center and H is on the circle, what would be the distance here? Our radius. That's the radius of our circle. Okay, the next thing is point G. Point G lies somewhere on the circle. I don't know where, but I know wherever it is, it creates an angle with the center of my circle. Point T is the center. That's a 45-degree angle. So I'm going to guess that point G is about right here, because then when I draw this line, this little well, before I do anything else, I want to highlight this. Oh, I knew it was going to smear the pen. All right, this little angle right here, it tells us is 45 degrees. Okay, so this is all we know. G and H lie on the circle. H to T is 8 meters. This angle GTH is 45 degrees. Okay, so the question is, what's the length of this arc? Not the degree. We know the degree measure of the arc is 45 degrees. An arc measure is the same as the central angle. We want to know the length of the arc, okay? So we're going to come up with a little ratio. So the ratio is going to be, I'm going to say our arc over the whole circle, okay? So we're going to write 2 ratios from this. So when we first talk about degrees, on top, our arc is 45 degrees. The entire circle is 360 degrees, right? If we talk about length, our arc, we don't know what the length is yet. We're going to call it L. And the entire circle, what's the distance or the length around the entire circle? Well, that's the circumference. Can I figure out the circumference? Circumference of a circle is 2 pi r. So do I know the radius? Yes, it's 8. So 2 times pi times 8, which would be 16 pi. So I can put 16 pi here. Okay, so now I've got this proportion right here. 2 equal fractions, 2 ratios set equal to each other. So to solve for this measure, I'm going to cross multiply, right? So I'm going to multiply 45 times 16 pi and set it equal to 360 times the length of my arc. Remember, this ratio is degrees. This ratio is in length of the circle. Our little arc length versus the entire circle length. Okay, so I'm going to write 45 times 16 pi equals 360 times L. And I'm solving for L. That's the length of my arc. All right, so 16 times pi equals 50.27. It says round to the nearest hundredth, so we're going to round that to 50.27. 45 times 50.27 equals 360 L. Then I want to multiply it times 45. 2261.95. 2261.95 equals 360 L. And then I want to divide both sides here of my equation by 360. And then these 360s will cancel, so I'm left with L. And then I just got to figure out whatever this is. So it's still here. I'm going to hit divided by 360. And I have to round to the nearest hundredth, 6.283, blah, blah, blah. So 6.28. 6.28, and that's in meters because the radius was in meters. So the length of my arc is 6.28 meters. The length around the entire circle is over 50 meters. And the length of just my little arc, so 50 meters, this guy is just over 6, like 6 1/4. Okay, so let's look on our test and make sure, our review, and make sure that's one of my choices. 6.28 right there. F for number 6. That was a really long one, sorry. Number 7, in circle X, chords A, B, and CD are congruent, and AB is 9 units from X. Find the distance from CD to X. All right, so we're going to draw this. We've got our circle. This is circle X, okay? And it tells us there's 2 chords, A, B, and CD. So we're going to draw one here, A, B, and we'll draw one here, C, D. Okay, it says they are congruent, so this is equal to this. And then we learned a rule that said if 2 chords in a circle are congruent, they're equal distance from the center of the circle. So it says AB is 9 units from X. So the distance here is 9. And the question says find the distance from CD to X, from this line to X. Well, if this is 9 units and this chord is the same size as this chord, then this has to be 9 units. Okay, so our answer here is B. Next, number 8, determine AB. And here we go. So we've got to recall some past information or past rules we learned about specific types of triangles. We're always building in geometry. You can never just forget what we learned before. Okay, so we're looking for the length of AB, this entire line right here. What do I know? I know this is a triangle right here. It's a right triangle, and it tells me this bottom corner is 30. So if this is 30 and this is 90, this top guy has to be 60, right? So I'm looking at a 30, 60, 90 triangle. This is 30, this is 60. Okay, so this is my short leg. I didn't do a very good job drawing this. This is my long leg, and this is my hypotenuse. It also tells me that this distance, the short leg, is 4 units. Okay, so what do I remember about a 30, 60, 90 triangle? Got a short leg, a hypotenuse, and a long leg. The short leg, to get the hypotenuse, we just double it. Remember that with a 30, 60, 90? So if I double the short leg, I get 8. The hypotenuse is 8. And then for the long leg, I'm going to multiply the short leg times the square root of 3. Do you guys remember that? We had 45, 45, 90s and 30, 60, 90s, special case right triangles. So 4 square root of 3. Another thing you could do here is Pythagorean theorem, right? 4, we know to double it, we get 8. And then we can use Pythagorean theorem to find the long leg, which ends up being 4 square root of 3. Okay, well, that's all fine and good, but that's just half of this right here. 4 square root of 3. And I know if this line is perpendicular to this chord, then I know it splits the chord in half. So this side is congruent to this side, which means this has to be 4 square root of 3. So the entire thing is going to be 8 square root of 3, which is answer choice H right here. Hopefully you guys can kind of put that 2 and 2 together and figure that out. This is not just isolated to just this chapter. You've got to remember the stuff you learned earlier too. All right, number 9, find X. This one's a little easier. Here, this is just this chapter. We've got this picture of this inscribed angle here, 72. Think of it like a flashlight, right? And it's shining onto this arc. This is an intercepted arc. It's an arc created by this angle right here. And so an angle is always half of its intercepted arc. The intercepted arc is always double the angle across from it here, right? It's the same, the arc is the same size as a central angle, but when you stretch that central angle all the way across the circle, this arc is double that angle. So double 172 is 144. 144 degrees, which makes sense. If the entire circle is 360, half of that would be 180. This is just less than half. Makes sense. So our answer choice here is C. Number 10, almost done with the front here. The first video, number 1. Number 10, triangle JKL is inscribed in circle P. So let's just go ahead and draw circle P. Triangle JKL is inscribed in it, which means all 3 corners of that triangle are going to be on the circle somewhere. It says JK is the diameter. So here's JK, and I've got to put L somewhere so it makes a triangle. And the measure of arc JL is 130. So it's going to be pretty big. All the way to JK is 180. So from J to L, it's going to be like probably around here, right? So we're going to have this guy and this guy. There's this triangle. It's inscribed in our circle. All the corners lie on the circle. One side is the diameter of the circle. And then this arc right here, I'll do it in red, is 130 degrees. Okay, so then the question is, find the measure of KJL. KJL. We're trying to find the measure of this angle right here. Okay, well, what do I know about this? I know that an angle in a circle is half of its intercepted arc, right? So if I'm looking at this angle right here, it stops here and it stops here. This is the intercepted arc. This is 180 degrees, right? Because it's also the diameter here. So for this angle, this has to be a 90-degree angle. Okay, what else do I know? I know this arc is 130 degrees, and this is an intercepted arc across from angle K. And remember, an arc is double the inscribed angle across from it. The angle is half the arc is double the angle. So what's half of 130? 65. So if this is 90 and this is 65, that's 155. What does this angle have to be? 25 degrees. 180 minus 155 is 25 degrees. So our answer here is F, 25. I hope that makes sense. You got to think of it as a few different things, right? We've got our angle here. We've got this guy. This is 130. So the angle across from it has to be 65 degrees, half of it. We've got this other angle here. If we think of this, right? Ignore this for a second. This entire arc is 180. It's across from this guy, so this has to be a 90-degree angle, right? So once we know two of those angles, this is 65, this is 90, then we can just subtract from 180 and we get 25. All right, last one for the first page. Number 11, the measure of an angle formed by two tangents to a circle is 90. If the radius of the circle is 8 centimeters, how far is the vertex of the... Okay, so these get really tricky. All I would do when I start reading this stuff is jump right in and start drawing my circle because it's going to make more sense when you see it, right? It's a lot of words otherwise. Okay, measure of an angle formed by two tangents to a circle. So here's my circle. Two tangent lines means they brush past the circle. So, boom, let's say that touches my circle here. And, oh, that was supposed to touch my circle here. That wasn't a good line. It's supposed to be tangent, sorry. All right, two tangent lines meet up right here. And it says they form a 90-degree angle. So this is 90. Okay, if the radius of the circle is 8 centimeters, oops. So this guy right here is 8 centimeters. Same thing here. This is 8. How far is the vertex of the angle from the center of the circle? So basically, what's the distance? This guy right here. What is that? Okay, so we know when two lines are tangent to a circle, the length from where they meet up to where they each touch the circle is congruent, right? So this is equal to this. And I know that this is a 90-degree angle. And so when it goes straight, when it cuts straight here, it cuts this angle in half, right? This vertex is going straight to my angle. It's cutting it in half. These two sides are congruent. I know this is cutting this in half. So half of 90 is 45. So this is a 45-degree angle. This is a 45-degree angle. I also know that when a line's tangent to a circle, the radius is perpendicular to the line, which means this is 90 and this is 90, right? So what do you notice here? I'm going to just focus on one triangle. I'm going to focus on this one. I've got a 45-degree angle, a 90, which means this angle's got to be 45 as well, right? So I've got a 45, 45, 90 triangle, right here. Boom, boom, 90. This is 45, This is 45, which means that both of these are congruent, right? I know one of them, the radius here is 8, so that means this distance has to be 8. And for a 45, 45, 90, remember we have the leg, they're both the same, and to get the hypotenuse, we multiply the leg by the square root of 2. Okay, that's, I know, back in the vault, you got to look that up. So short leg, or one of the legs, they're both the same size, times square root of 2. Right, so then the length, the distance, this distance right here, from the center of our circle to the vertex of our, where they intersect, is 8 square root of 2. And that is an answer choice right here, 8 square root of 2. Okay, real quick, remember 45, 45, 90. These two are congruent. We've got x, they're both the same size, and to get the hypotenuse, you multiply by square root of 2. Remember for a 30, 60, 90, you've got one leg way longer than the other. This is 90, this is 30, this is 60. We've got our short leg. The hypotenuse is just double the short leg, and the long leg is the short leg times the square root of 3. Remember that, recall that. You need to remember that for your circle stuff, okay? Stay tuned for the second video.